Hello, everyone, and welcome to another episode of The Next Generation of Energy, a Rosewater Energy podcast. I'm your host, Daniel Litwin, the voice of B2B. And folks, thanks so much for joining us on another episode of the podcast. We appreciate you tuning in as we explore topics, trends, and offer you some actionable insights on the larger world of energy and its various evolutions. So as we get into today's topic, I want to make sure you're all caught up on previous episodes. So make sure you're heading to our website, rosewaterenergy.com. There will be plenty of useful resources, especially on the topic we're breaking down today, but also other content, including previous episodes of the podcast, blogs, white papers, videos, you name it. So head to the website, rosewaterenergy.com, and subscribe to the Next Generation of Energy on Apple Podcasts and Spotify so you don't miss out on future episodes and also have your full catalog of previous ones to catch up on. So let's jump in, folks. For today's episode of the show, we're going to be drawing some distinctions and clearing up misconceptions around a common point of misunderstanding we found when determining the efficiency of power sources and power use. And that would be specifically the difference between power quality and power reliability. So as I was thinking about what to discuss on this podcast and was working with the Rosewater Energy Group, it really dawned on all of us that the level of awareness around battery storage and power quality has greatly expanded over the last few years. And much of the conversation around, for example, battery storage as an extension of renewable energy has been around reliability, right? This concept of generating and then storing energy via solar, let's say, and then having it accessible in a pinch, right, would reduce costs theoretically for residents, but can also insulate against potential outages. And, folks are a little more knowledgeable on this realm of how energy relates to their day-to-day. But that doesn't mean that the wealth of knowledge around these specific technical differences between, for example, power quality and power reliability are all that clear. And for good reason. It's a pretty intricate and layered side of this industry. So what we wanted to do with this podcast today is expand on those differences, right? What defines both power quality as well as power reliability? We lay out how they're different, but also how they intersect. And hopefully this will clear up some of the nuances of both so that our listeners can better gauge how efficient and efficacious their power sources are. We're also mixing something else up here. On the podcast today, if you've been listening for a while, you may have been expecting Mr. Tyler Kern as y'all's hosts, but we're going to be changing it up. As we move into 2023, we wanted to bring in some new voices to help guide important conversations in our industry. And I'm not talking about my own voice here. No pats on my own back. Today, our podcast is actually going to be co-hosted by another industry pro who will help bring his perspective in renewable energy and the larger energy industry to our conversation to give y'all some grounded examples in practice of the importance of power quality, power reliability, and their differences, again, in practice. So let's go ahead and welcome both our co-host and our guest. First up, as our co-host, Mr. Carl Kasalek. He's CEO of WattLogic, which is a leading provider of EV charger installation services for both commercial and residential customers and a full range of EV solutions. Carl, thanks so much for joining us. Welcome as co-host. How you doing today?
Absolutely. Glad to be here. Thanks, Daniel.
Yeah, man, it's a real pleasure getting to do this podcast with you and, pull from your experience to help inform our discussion. Just so our audience fully understands, can you give us that elevator pitch timeline of your journey through this industry and some of the touch points that you've had with the different markets within the energy industry?
Yeah, absolutely. Actually, my energy experience comes from a very young age, growing up in my father's electrical contracting business out in California, kind of everything from pulling wire in the field to helping build electrical panels and sweep warehouse floors when I was really young. And so got just naturally through osmosis exposed to a lot of things going on. And naturally that led me down an entrepreneurial road of really focusing on energy efficiency in similar environments. So much of my experience is in large industrial settings and manufacturing plants and helping to manage the energy footprint of those facilities and bring them solutions. And as our times have evolved, that's brought our company, WattLogic, into the renewable sector. Most recently, putting a lot of energy behind the electrification of mobility and vehicles for fleets and, like you mentioned, even home residential use.
Fantastic, man. Well, I think that, breadth of experience and knowledge is going to give our audience a lot of, like I said earlier, grounded examples of why power quality and power reliability should be treated as different, but also how they can manifest themselves in practice, in the field. And, I think that's just going to help give us some grounded perspectives. So thanks again for joining us. And I'd like to go ahead and welcome Mr. Joe Piccirilli, CEO and Managing Director of Rose Water Energy. Joe, welcome back to the podcast. How you doing?
Well, thank you, Daniel. And welcome, Carl. It's a pleasure to hear your background and have you on our podcast. And I'm looking forward to having you on many, many more. For many of our audience, they know sort of my journey in this industry. I was working on a graduate degree in engineering a long, long time ago and dropped out of graduate school to start a consumer electronics retail store, which I was fortunate enough to take public in the 80s. And then along my journey, I started another company that specialized in servicing system integrators and custom installers who were doing the very, very early days of automating homes and evolved into installing the networks and things connected to the networks. And what I noticed was that there was a tremendous amount, particularly in the mid-90s, it sort of peaked. There was a tremendous amount of customer dissatisfaction with all of this really what was supposed to be cool gear. And so I was curious why. And, since we distributed the gear, I took it off our shelves and took it all apart and looked at build quality and part selection. And for the most part, the build quality was excellent and the part selections was extremely good. And then I started analyzing the installation of the gear out in the field, and with few exceptions, the installations were also extremely good. So that led me to, well, wait a minute, what's the problem? And the problem was power quality. And it was, it became sort of an aha moment when you're sitting there saying to yourself, oh, wow, we are loading houses with microprocessors, and we are not compensating for the fact that microprocessors hate voltage fluctuation. They don't want to see 140 volts or 100 volts or even 105 volts. They would like to see 120 volts. They work better, they last longer. So at that point, I decided I think it was 10 years ago, I decided I would build a residentially focused high-end power quality device. And I wanted it to be a complete solution. And I thought it would be a fairly easy design task. And I couldn't have been more wrong. It took me 4 years to develop the product, find a manufacturer who would build a product to my specification. And that's how we embarked in the power quality journey. Again, so that's how I got here. It's interesting that Carl and I ended up in the same place from two totally different beginnings. It was, that's kind of cool how, it makes me feel like, wow, this residential thing isn't, because I don't know about you, Carl, but when you're starting out and you're taking these really high quality devices and all of the things that you're focused on that are generally in the commercial world, and there you go, well, yeah, these are going to be really cool in residence. I had people look at me like I had 4 heads. That was never going to happen. But here we are, and it's a wonderful thing. So,
well, let's kick off the podcast then by just getting right into the definitions, right? Again, we're trying to discern for our audience the differences between power quality and power reliability, and how the general environment right now of energy solutions and how people are engaging with their power use is creating both more opportunities to better understand the differences between these two fronts, but also confusion around why these things matter separately and also together. So let's start by drawing some of those initial distinctions. We'll start with you, Joe. How would you define the differences between power quality and power reliability if you had to give just a basic summation and compare and contrast?
When you are talking about power reliability, you are generally referring to something that can react to a power outage by a utility. So it would mean if there's an electrical outage that lasts more than a couple of minutes, you would have some form of backup to replace the utility. To me, that is how I would define power reliability. And there's lots of products out there that do that or claim to do that. Power quality is an entirely different issue. A power quality device functions 100% of the time. When the grid is working, it is cleaning up the power from the grid. When your backup devices are working, it is cleaning up the power from your backup devices. And it is ensuring that regardless of input, regardless of source, the output from a power quality device is always perfect. It is frequency consistent, voltage consistent, and it is amperage consistent at all times. So that is the difference. It really is this device. Our devices are engaged 100% of the time, and that's what people really. That's where the confusion lies because our device has big batteries and everything else. Oh yeah, you're just battery backup. No, that's kind of the least of what we do. So I think that's about as concise as I can give it. Carl, do you have anything you want to add to that? Because I always think I'm explaining it clearly, but people tell me I'm out of my mind.
I agree 100% with what you said as far as the definitions. What I'll try to add is maybe some analogies related to it. So I think that power reliability in a home or a business, the first thing people think about is generators. Nowadays, that conversation is shifting a little bit to batteries, and I think we can touch on that a little later. But just a day-to-day application of it is most people are using laptops nowadays. Desktops have kind of trended out. Now, power reliability for a laptop means that you're plugged in at home, the power goes out, you can keep working because now your laptop transitions to battery. Or somebody kicks the cable out, you're working at Starbucks, they kick your cable and it comes out, your computer doesn't shut down because it transitions over to battery. And so your computer is handling that transition between the two as that happens. On the other hand, power quality, I would relate more towards your heart. So you go to your heart surgeon, what do they want to see? They want to see these nice, similar to electricity, even sine waves of your heart, a rhythm that's consistent. Every beat of your heart looks relatively the same. Now, if you have an issue with your power quality, much like if you have an issue with your heart, you have inconsistencies in that wave. And that's where we start to worry because that causes problems in your body. Similarly, the microprocessors that Joe speaks of in your home that are all over the place have the same issue, is they don't like to see that minor influctuation. Even if it's a millisecond, it starts to cause ripple effects downstream, much like we see in kind of the human heart. And so for those that, just to kind of remove the technical veil of things, think about it. We've all kind of seen a heart monitor and things move across. You want to hear that nice even beat, that you want to see that wave move across the screen evenly. And when that starts to get disrupted, which it does a lot in an industrial setting, in a home setting, and we're seeing more and more of it as we see more devices come online, more processors come online. That's what we're talking about when we're related to power quality.
Good. I like that.
So then, if we had to look at this distinction between power quality and power reliability applied in practice in both of y'all's service and solution areas today, how do you see that manifest, either on the Rosewater side or on the WattLogic side? Feel free to break that down.
Well, I think from our point of view, power quality, in the past, power quality devices were very specific to pieces of equipment. People would have a power quality device hooked up to an audio monitor or a television. That would be very specific and very small. Because, as we've discussed, of the proliferation of microprocessors throughout the entire home, at Rosewater, we decided we would build devices that work at the panel level, which I'm sure Carl's seen on the industrial side all over the place because that's the industrial footprint. So we started building devices that would take all loads that are deemed critical in a house and power them from the panel level. So from our standpoint is we want to guarantee perfect power to every critical device, microprocessor intensive, in a home. And we're talking off air, Daniel, when we're saying, years ago, the consequences of a voltage sag or surge was your digital clocks blinked. That was the big deal. You had to go set your clock, and neither one of you are old enough to remember VCRs, but one of the big deals was you had to go reset your clock on VCR, which was painful because it was just illogical. So, from our point of view now, the consequences today, because houses are so automated, if you have automated lighting, automated controls for your HVAC or environmental controls, so many things, what happens is if a microprocessor goes, you don't have to just reprogram. In many cases, you have to replace a microprocessor. And for instance, in lighting control, if a microprocessor blows, you can't turn on your lights. That's problematic. And as microprocessors migrate into more and more functions in the house, the consequences of microprocessor failure or reboot are much more severe than they used to be. So that's why Rosewater exists. That's why we build. Our smallest device is 100 amps, and it gets larger from there. So that's what we're about.
Great. And yeah, from an industrial perspective, absolutely. This is something that's been around for a while. And actually, many of you have probably seen it without realizing it. One easy example, and hospital is a great place that you would see it, but even in offices, is if you see an orange electrical receptacle, even in an office environment or a server room, in an industrial setting, that's referred to as clean power. And it's reserved for devices because they've seen machines and equipment have failures and early failures beyond their proper age because of power quality issues in an industrial setting. Now, the reason you've seen more of it in an industrial setting is just the scale and size of the equipment and space, and just the cost ramifications, right? If you have a $1 million MRI machine go down, not only do you have the cost of the machine and getting the repair tech out, but you have all of the billing that you miss by having that machine go down. And so that's why we've seen, I think, a lot of that form and this technology get refined in the industrial segment. And so I think it's exciting personally to see that begin to enter the home, because in both spaces, we've seen just a race to exponential technologies taking over, right? In an industrial setting, used to have conventional manufacturing lines that were a lot of motors and really simple pieces of equipment. Nowadays, all of those motors are driven by VFD devices that control the speed and flow. There's automated sensors that are detecting where equipment is and responding accordingly and rerouting even your packages that you see in like a FedEx facility. There's miles of conveyors that are all electronically controlled. And there's computers at the helm running all of that, much like there is in your home. So when you have these home automation devices, everything down to your computer, and like you mentioned, home thermostats, I think there's a lot of things that people don't think about as being electronic. But even take the thermostat, right? The thermostat used to be this very simple mechanical device that you slid in, it turned on, off. Nowadays, most people have Wi-Fi connected thermostats with smart scheduling. There's infrared sensors that detect if you're there or you're not and respond accordingly. It monitors the weather outside. There's so many extra layers of complexity that we're potentially putting all those devices at risk if we're not protecting those downstream and providing something much like these industrial facilities now have done for years. And so I think that's where it really becomes important in a power perspective today, that it's much more pertinent as our homes are kind of a large functioning network versus just being something that, we sleep and we eat in, right?
It's a critical point, because when I looked for a manufacturer to build our product, I ended up looking at, okay, who are the people who build the best industrial product? And then, because to your point, Carl, the industrial world is far ahead of the residential world on the importance of keeping this product running and your microprocessor running. And people don't think about, you think about an MRI machine, which I think is a great example. People think, well, that's an expensive machine. Well, no, if it's down for 2 days, you've just lost a lot of money, a lot. So, and what we had to do in the residential world, it was interesting because I looked at all the devices, and noise is not as important in the industrial world. Electronics, hash, all of that is not as important. So I had to go to those manufacturers and say, okay, product reliability, reliability is excellent. I love the fact that the components are hot swappable. This thing never has to be taken offline, which are all the things I wanted in a Rosewater. But then I said, okay, so see those noise specs? They've got to go down by 20 dB at a minimum. So, it was interesting because it is, we've grown.
Real quick, let's address that real quick, because I want to make sure that you and I think, get that on the noise that these devices produce. But I think that is an important point to touch on, because I think for an average consumer, noise to them might be, I'll give an example. Many people have converted to LED lights in their home. When you put those LED lights a lot of times on a dimmer switch, all of a sudden you hear this like buzz over your head and you're trying to watch a movie and you're like, what is that buzzing that's going on overhead? So I just, if you can kind of dig in a little deeper on noise and what this looks like, I think that'd be really helpful for people to see.
Well, when you start to talk about noise, first segment of noise, you're talking about electronic and noise that affects the actual sine wave. So that you are sitting there saying, I don't want to hear the hash, so to speak, that would pass through the device that in a critical, in an industrial setting wouldn't matter. But in a home, for instance, that noise level affects the performance of amplifiers. It affects the performance of your television. It affects the performance of very critical microprocessors. And to be able to get rid of the noise that is generally generated by the more critical your inverter, the better the sine wave it makes, the more chance of it producing noise, because it is converting an analog signal to a digital signal and then back. And that's where the noise comes from. Most people aren't aware of that noise until they have discerning equipment or an LED light with a dimmer. It is interesting you bring up LED because, the LED lights are all, okay, this is supposed to last 10 years. And they don't. And they don't, mostly because noise and sags, they don't last. And I don't know if either of you have any of you seen the most recent LED lights where you can adjust color temperature at the bulb? So if you have 200 bulbs in your house, you have 200 microprocessors right there that are all susceptible to noise, that are all susceptible to voltage sags in particular. So that's really where we needed to make our device quieter, and we did.
Excellent.
That's the world that we come from, and it is important, and I know Carl knows this, in the industrial world, there are a couple of manufacturers who are top of the heap. These guys, you go to mission critical facilities and they have it. And one of the people who manufacture our products are actually one of the 2 or 3 top of the heap guys. They build extremely good product, and we've made it better. And again, it was a marketplace that no one saw. No one saw it.
And now why, if, again, I'll pull myself out of the industry as much as possible. As a consumer, I think the first thing I would ask is, why do I need something like this in my home? Can I just buy better products? So is me buying an Apple computer versus a Lenovo computer, does that mean that the Apple computer, because I'm paying twice the price for the same system, have more power quality features and everything else? Or if I'm buying LED lights, if I buy the top of the line brand versus the Costco special, am I going to see that difference? Because I think sometimes that's the expectation from a consumer's perspective. Is I pay a premium, why doesn't this thing have all this built in already? Why do I need something in addition to that? Can we touch on that for a minute?
Absolutely. And I know that every manufacturer tries to build something in to protect their product from voltage fluctuations. There is no question. However, it is the ability for the unit to not have to do that allows maximum performance. And in fact, the higher the quality device you buy, the more you want to feed it clean energy to get the performance you're paying for. If you own a high-priced sports car, let's assume you own a Porsche. Does it run better with regular gas or premium? And you want to take, and I am paying for a level of performance. I must feed this device the best possible power fuel I can to maximize its performance. And it is, for our clientele, the people with the most discriminating equipment see the benefits more than anyone else. So that would be my analogy for those out there. The higher the performance equipment, the more you want to be careful with what you feed it. The example that Carl pointed out with LED bulbs, the bulb's not going to change the problem. It's not going to help. No matter how high quality the bulb is, it will create noise if what you're feeding it is not correct. So that's the way I would address that. And I think more and more consumers are seeing it. I run into issues constantly where people are saying, why did I do this? It's interesting. Wolf makes ranges, right? They make really high-end ranges. Now in a Wolf owner's manual, they talk about having to reboot the microprocessors on their stove. So think about what that, they're anticipating that they have power problems. This has to be rebooted. And, you're seeing it in washer and dryers. You're seeing it in refrigerators. It's interesting where, as you talk about, and you're talking about Wolf is a seriously premium product. That's not an entry-level range by any stretch of the imagination. And that's what we're seeing out there. And I see more and more people complaining about it. Well, I just spent, $20,000 on my range and now I can't use it. What happened? And people get angry and rightfully so. And unfortunately, they don't understand cause and effect. And that's what we're trying to get across. In the commercial world, you could point it out by saying, hey, you're generating X number of dollars an hour with this device. It's down. That number times the number of hours it's down. That's a pretty straightforward calculation. In a residence, it's more peace of mind. I paid to have this device available when I want it. And, you're sitting down and, okay, now, of course, you only have a problem the minute you want to use it. As a lot of the television and cable people say, these things only go down just before the Super Bowl. And from our perspective, we see the future of conditioned power in a home. It is my contention that within a decade, there will be panel level power conditioning devices will be as common in a home as a dishwasher. Because, as we were discussing earlier, before we went on air, in the healthcare industry, we're moving towards telemedicine and in-home diagnostic. Those all require connected devices with microprocessors. There is a movement towards monitoring the health of your home, air quality, water quality. How are your filters working? All of those things are microprocessor intensive, and people will begin to rely on them. As you pointed out, Carl, now it's not just a thermostat. There are thermostats that sense when you are in the room and adjust the temperature based on the number of bodies in the room. Well, it sounds really cool. It is really cool, but you have to understand what it takes to actually make that happen and how vulnerable those things are to power quality. So that's where we are in that. I think we are well positioned for that, for the transition to the electrification of our lives, basically.
So maybe it's, from a very simple sense, it's almost like having an insurance policy on your electronics and all the equipment that are running your home. And that when you see these warranted lifespans and that the devices on how long they're going to last, it really, from a very simple, non-technical perspective, having great power quality in your home is like having an additional insurance policy on all of that expensive equipment that you just, drop $20,000 on a range, like you said, and extending the life, because not only does it offer the insurance by that running longer, but it's actually more even like a maintenance plan of making sure that that is running optimally for its entire life, that likely in many cases will extend these units beyond even that warranted period of life that they have. Because you and I both know, but maybe the average consumer doesn't know here, that the critical point of failure in many of these devices nowadays are power related. So talk about LEDs. It's the driver that's the conversion component to take AC power to DC power, which is where the failure is happening. It's not the actual LED. And people get upset that this LED said it was going to last 200,000 hours. Right? Yeah, the LED will. That doesn't mean that downstream, the power device that's driving it will. And so unless we have a means of protecting that driver or that power converter, then we're not going to see the life that we expect out of the devices that we buy.
Yeah, I agree. I've been looking for a while for a better answer than an insurance policy, because an insurance policy only pays when the thing's broken. And I'm sitting there saying, no, this is the guardian at the gate. This is going to prevent the enemy from coming in your house. And I'm trying to get a better analogy than that. But that's the thing. This prevents the need for insurance, basically. This says we are not going to allow failure. And it is interesting in our field experience with these devices out there. I've had homes that have, just before the device went in, we're getting service calls 6 to 12 times a year. I mean, power quality was terrible. And I just finished doing a little case study, one house that's had the device for almost 4 years now. Prior to putting a Rosewater in, by the client's own admission, they were going through somewhere between $30,000 and $50,000 worth of gear every year. Not to mention the failures that didn't result in a product failure, but just inconvenience. But then every year there were huge product failures. In the last almost 4 years, they've had 0 incidents. Not only no product failures, no incidents of being down. I mean, they're just ecstatic. And to one of the earlier points when we were talking about the importance of minimizing noise, in this particular household, there's a real audio video file. I mean, he has a serious home theater. And I got to listen to the home theater before our device went in, and then I listened to the home theater after the device went in. I knew there would be a difference, but the difference was not subtle. It was, yes, it's just like, whoa. Because you were talking earlier, do these manufacturers build things in to protect themselves against power quality? And yes, they do. But when the power is of high quality, they don't have to work as hard. And it was like a veil was lifted off this system. It was incredible. I mean, and obviously I'm not objective, but I was actually, even for what I expected, I was stunned at just like, wow, that's huge. So it's, I think that this truly is the guardian at the gate. That's what we're looking at. And that's what happens in the industrial world. Your MRI example is so appropriate because, that is there to generate revenue, 14 hours a day or however long they're open. And they never want it to go down. That's why they will spend a lot of money for a guardian at the gate. Nope, we don't want any chance of this thing failing.
And I think on that helpful note, we'll go ahead and wrap up the podcast. Carl, Joe, it has been such a pleasure getting to sit down with both of you today and draw some distinctions, some intersections, and highlight the importance of power quality and power reliability, especially in this age of industrial digitization, right? But also residential electrification of and digitization as well of various aspects of our day-to-day. As that continues, it's definitely not slowing down with the rate of smart device adoption and both in the industrial and residential setting. I think we're going to have to continue this conversation, which means there might be an opportunity to have you both back on soon. But in the meantime, thank you again to the two of you for your perspectives. Again, folks, as our co-host, we've had Carl Kasalek, CEO of WattLogic, and as our guest, Mr. Joe Piccirilli, CEO and Managing Director of Rosewater Energy. Carl, if folks want to find out a little bit more about your perspective on this topic, or maybe get in touch just to source you as a partner or to pick your brain on some other thought leadership, how can they get a hold of you?
Yeah, either going to wattlogic.com, or my name's spelled CARL and my last name's KASALEK. And you can find me under that on all social media, from LinkedIn, Twitter, etc.
Fantastic. And Joe, same question to you. How can folks get in touch if they want a little more information, or where should we point them to further expand their breadth of knowledge around the difference between power quality and power reliability?
Our website is rosewaterenergy.com, and there's a tremendous amount of information on there, including how to construct a power plant for your house. All of that is on there. Getting a hold of me is also not so difficult on social media. My last name is spelled Piccirilli. If I is the only vowel, you're spelling it correctly. First name, Joe. And Daniel, I did want to say, you started out the podcast saying, you weren't looking for a pat on the back, but, here's your virtual pat on the back. Nice job.
Thank you. Hey, I'll take it. Thank you, my friend. But yeah, fantastic. Folks, you heard it there. There's 2 websites and 2 gentlemen here to reach out to with any questions, and we'll continue to explore this topic here on the podcast. So make sure you're subscribing. And this has been another episode of The Next Generation of Energy, a Rosewater podcast. Head to rosewaterenergy.com for previous episodes. Subscribe on Apple Podcasts and Spotify, and we'll be back with more expertise, thought leadership, and actionable insights here very soon. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode.